those hardware runners. So, yeah, a bit introduction. I'm regular project contributor. I work for Invisible Things Lab and Qubes OS. So, as Stefano said, but the basic idea is you run Gitlab runner somewhere, which is a very simple binary that is starting usually containers. And in addition to this Gitlab runner, you have a connected system under test that will actually execute the test. So Stefano was talking about the setup for ARM board, and the controller was x86 workstation. So in my case, I'm talking about x86 target systems, system under test, that are controlled from ARM64 controllers, Raspberry Pi specifically. So it's reversed here. So there is a rack with a bunch of hardware. This photo is, I think, a year old. Now this rack is full, and there's no space left for more hardware. Just to have it nice, I added LED strips signaling the state of each machine. And specific runner looks like this. We have the target system itself. It's the PC in the middle. This one is specifically the Intel runner that is connected to Gitlab CI. A little correction, it's Alder Lake, not Skylake. And the thing you see on the left is a Raspberry Pi that is connected to it. It's connected, it's controlling, it has USB connection for input emulation. We don't use that with Zen tests, but it has also a serial connection. There is also HDMI output that is Raspberry Pi is grabbing. We also don't use that on Zen test yet, at least. But most importantly, the Raspberry Pi is running Gitlab runner. So what the Gitlab test should do here? So fetch artifacts, this is standard thing that Gitlab will do. Assemble boot test files. So this is about preparing root file system. There's this RAM disk for DOM0 and potentially some DOM-U. Maybe some bootloader configuration. With x86 tests, I use Grub to boot the system, so it's group config with all the kernel parameters and Zen parameters that are required. For example, to set up the console, to use the correct in RAMFS. Then put those files in the right place. That right place is a directory that is published, that is exposed somehow over the network. Since I use Grub, I can use HTTP, not TFTP, to fetch those files. It's just a bit faster, especially for almost 200 megabytes RAM disk. So that's what I use here. Then start the target system. Similar to the setup Stefano described, there is some way to physically connect the power to the system. I use those USB-controlled power strips. So, yeah, as you've seen, there are several machines. So I have each of them has 4 ports. So I have several of those connected to yet another Raspberry Pi. Then interact with this system, look on the serial console, see if the test passed, and finally shut down the system. So specific details. The system components look like this. The host on the left, HAL 9000 number, these are Raspberry Pis that are running GitLab runner. There is one Raspberry Pi per the target system. It was looking like a smart choice to choose Raspberry Pi when I started to develop this for Qubes some years ago. Later, buying Raspberry Pis was a bit challenging, I would say, but somehow I can still manage. Then there is the system under test, and there is the connection I was describing earlier. As for the Berta comment for security implication, each of those Raspberry Pis and the target system are running in a separate VLAN, isolated from all the important stuff from the network. So tests cannot interfere with each other, cannot interfere with other network services. So that's how it works. There is another Raspberry Pi on the top called Tor in my case. This is the controller that is managing boot files, managing power control, the LED strip, the important part. And this is and there is also a bit orchestration for other CI systems connected here, especially OpenQA. I will mention it later also. So from the GitLab runner perspective, there is some extra stuff injected into the container. The test has access to SSH agent with a key that allows it to connect to the controller to trigger specific test. Controller authenticates, there is a policy which SSH key can control which runner. So here the host on the top is connected to control power for all the boards, but the policy is, which board is controlled is set based on the SSH key. And there is also a shared directory that is published over HTTP. So the extra parts to the GitLab runner configuration look like basically like this. So there is the environment variable to set the SSH socket, and the SSH socket is connected like this in volumes. There is no secret here. I just made it to fit on the slide a bit shorter. Later, there is a link where all the configs are published. I have also those two scripts here, GitLab Runner started and GitLab Runner complete. Those are to coordinate with with other tests, especially OpenQA and also some bisection tests I do on the same machines. So when GitLab is starting test, it's reserve the runner and prevent other tests to interfere with that, basically shutting down other services. And those services, those scripts are also injected from outside to the GitLab, to the Docker container. There is also a SSH known host for this connection and the shared directory for the boot files. So how the startup works? The GitLab runner start claims the system it will use for the test. This shut down OpenQA. First, it checked if the runner is not, the system is not used for anything else. It shut down other services that could potentially use that. Then place boot files in the shared directory and SSH to the controller to select which boot mode to use. This points the grub configuration to the one put in the GitLab by GitLab in the directory, and then power on the system. Then system under test loads the group to UEFI, either with PXE, or if there is no network boot support in the firmware, then there is a USB stick plugged with IPXE that loads that group. Probably using group here is not the simplest idea, but since I have several machines, this is something that gives me a uniform way to start the system. So I have several ways how to reach group, and then from group I can also start several different things. So that's the common denominator here. Group config then loads settings for the specific system. I use MAC address of the system to differentiate which settings to load. And those settings have parameters like what to actually boot. And specifically for GitLab tests, it adjusts the net default server variable to redirect requests to the Raspberry Pi with the GitLab runner, and then a load config file from using HTTP. So back to this picture. First, the initial group config is loaded from here, and then when it detects it's configured to boot GitLab CI control job, and then load another config, like chain loading config from the Raspberry on the left. Okay, so as I said, I have several ways to boot the system. The very power on procedure is depending on the system. It might be different. Ideally, when I connect the power to the system, it should automatically start. It is the case for most ARM boards, if I understand correctly. But for laptop or PC, not always the case. Sometimes there is a firmware setting to automatically power on when you connect the power. Sometimes it works, sometimes it doesn't. So sometimes I have basically 3 ways. One is this automatic power on works. Another, if it doesn't, I can try to wake on LAN. Sometimes it's enough. But if it doesn't, I have a servo motor that presses the power button. Yeah, and this works. By the way, I use the very same method for S3 test to wake up the system. So the test signals on the serial console, it's going to sleep. Then the controller board waits some time, I don't remember, half a minute or something like that. And then SSH to controller to trigger the press the button to wake it up. I forgot to put a photo, but it's quite funny. Okay, so when the system is powered on, then as said previously, there is either PXE if firmware supports network booting, or there is IPXE from USB stick plugged into the system to boot from. And then finally it gets to group, which allows me some scripting to control what to actually boot. So I can start to the system from the local disk. I can start system either directly from local disk, and sometimes group does not see local disk. For example, it doesn't have NVMe driver, so then I set next boot UEFI variable and reboot the system. Or load something from the network. And this is the case, the custom case and rescue case. This is exactly what is used for running GitLab. It loads the yet another config, kernel, Zen, intramfs, DOM0, etc. from the network, and not use local disk at all. And then there is the test execution. So GitLab captures serial serial console. It's connected directly to this Raspberry Pi running GitLab runner, but to have uniform API, it goes through SSH back and forth to the controller. It's done this way to have uniform API for different tests too. As Stefano said, all the files necessary for tests are embedded in the TrumFS, so everything is running from RAM. This means that init_TrumFS is not a small one, but it's okay. And the test results are reported via serial console, so the GitLab runner scripts are monitoring serial output and see if they see a specific pattern that, oh, this test is okay. And if there is some extra action needed, like waking up the system from S3 test, there is it also echoes something, and the controller, the test script in GitLab runner is waiting for the specific string and then performs this action. And then finally there is cleanup. So it's powered off the system. I use in my script a trap bash command to have this cleanup executed in both success and failure case. It's okay. And then there is a script that release the runner, the system for other test runners. There is this whole setup just for GitLab is kind of overkill. If that would be just for GitLab, it could be made significantly simpler. But this is the GitLab use case here is secondary. I started this integration for OpenQA for Qubes. And we need several more interfaces there. For example, we use video output, we use USB mouse and keyboard input. We use different boot modes, not only just random files. We use also installing system on the disk and then booting from that disk. So there are several more pieces involved, and having that already in place, connecting GitLab to that was simply reusing those blocks. But if you are going to add just GitLab, some board to just to GitLab, it's probably easier to look at the Xilinx setup that is much simpler. But if you're interested in the details of this, some more details on this setup, there is an article version of this talk focused on OpenQA, but many details are very similar. And all the scripts and config files are published in the repository linked here. There is specifically a SALT formula to set up this Raspberry Pi runner. As I mentioned, I have separate Raspberry Pi for each runners. I have currently 11 or 12 of them. So yeah, I use some automation to set up this. I don't do that manually. And some future work, definitely more tests. Something I plan to add very soon is PCI pass-through test with stub domain, because currently the HVM tests are using only QEMU in DOM0. Maybe also capture video output. Hardware part is already there, so maybe we can just use that. On the runners connected to GitLab, there is serial connection in both of them, but not all the machines have serial connections. So maybe capturing video output would be useful in some cases. I don't know. Booting something from RAM disk, if that's some Alpine minimal DOM0, is fine. But if there is a need for some bigger bigger test, or maybe trying if Debian works or some other distribution. All those systems have some local disk. So test may involve installing something on local disk. This is an option in those runners. The local disk is basically a disposable thing. I do not assume anything on the local disk survives. So each test can wipe it out and install whatever it wants. That's an option. And also, we can consider multi-machine tests, especially for stuff like migration or something, if that's desirable. I haven't done that before, neither with GitLab nor OpenQA. So there probably will be some challenges, but maybe an option. We'll see. Okay, any questions?
You said that you use the power button in order to resume for suspension. Is there some problem with using RTC wake, which I think was the way more people do it?
Short answer, reliability.
Okay.
Sometimes it works depending on the hardware. On the machine specific connected to the CI right now, the Intel one, RTC wake doesn't work.
RTC wake does not work with PVA still.
Okay.
Yeah, I use RTC wake for S3 suspends in Qubes on some machines, but it not always works. It's hardware dependent.
Okay. And then I also wanted to ask about doing the last thing that you had about migration. Do you have pairs of identical machines in order to do that, or?
Yes.
Okay.
I have pairs of identical machines, and also it may be interesting to test migration between different machines. Yes.
Yeah, well, that may get a little bit tricky, but yes. Yeah. Okay, thank you.
To the point of migration specifically, you can obviously it's not a complete setup, but you can test a lot of migration just by migrating to localhost. The way the Zen migration stream works is that it's literally writing into a file descriptor and out of a file descriptor. So the suspend to disk and migrate are the same code path. It's just either putting the socket across a network to somewhere else or putting it onto disk. And certainly in ZenRT, in Zen Server, we do a reasonable amount of localhost migration testing in the cases that we want to do a test of a single machine. We do obviously do pooling testing as well, but you can exercise a lot of the interesting migrate cases on a single system. In fact, you get the extra fun case where you have two VMs with a different DOM ID that are logically the same VM for a period of time. That's good at finding corner cases.
Okay. And does it work with PV too, or no?
Yeah. Yeah, it works fine.
Okay.
The only thing you've got to, the only problem is you've got to make sure you've got enough memory for two copies of the VM side by side. But that's easy to arrange.
Yeah, both workers have 16 or 32 gigs, and the VMs we use in test are 1 gig or something. Yeah, that's it.
One other question. You said that RTC wake doesn't work on the Intel machine.
Yeah, I think so.
Isn't that an Alder Lake running Desharo? Where are our Desharo devs at the moment? Oh, they're in the other room. Okay, that really doesn't help.
Yes. Yeah. Me?